Hi there. So what I'm going to show you is a trick to solve systems of equations very quickly using your calculator. So here we have a systems of equations in 3 variables, and if you were to solve that by hand doing algebra, it might take you some time. If you're on a math test with limited time, you need to move fast. So that's where the calculator comes in handy. What you can do is you can utilize matrix methods to solve systems of equations. So look, we can build a matrix. We can basically say the same thing. It's an equivalent expression using matrices, basically. This first matrix, we call that the coefficient matrix, because it's all of the coefficients of the systems of equations. Like the first one, for instance, has 2x plus y plus z. Well, that's 2x plus 1y plus 1z, 2, 1, 1. That's why it has 2, 1, 1 there. Same with the second one, 2x minus y plus 2z. That's 2 minus 1 plus 2. And then again 1 minus 2 and 1 for the last one. And then over on the second matrix, it's the variables. So I say that these are equivalent expressions because it's like if this first matrix was multiplied with the second matrix, it would give you actually it would give you another matrix, and that matrix would look like this: 7, 6, 0. I'm talking a lot longer than you'll need to actually solve these problems. I just want to give you some of the theory. First of all, up here, these are like the dimensions of the matrix for a little review, and it's rows by columns. 3 rows by 3 columns, 3 rows by 1 column. So to multiply matrices, first you have to make sure that the inner dimensions are the same. Those numbers have to be the exact same. The columns of the first matrix have to be the same as the rows of the second matrix. Did I say that wrong? The columns, yeah, that's right. The columns of the first matrix have to match the rows of the second matrix, which is just saying the inner numbers have to match. And then the outer numbers, those are going to tell you the dimensions of the new matrix. So the dimensions of the new matrix are 3 by 1, which is what this one is. 3 rows and 1 column. So it's the same thing. You see, we got this matrices being multiplied, and we got systems of equations. But it's the same thing. So the reason that we do that is so we can throw this into our calculator, and we can do that really quickly. You just look at the systems of equation, open up your calculator, and you hit second matrix, and when you first open it, it's just going to look like, I guess I should have cleared it out, but it's going to say A, B, C, D, E, F, G. It just shows you all the names, all the matrices that you have. You tab over to edit, and you enter the first one, and you make it a 3 by 3 matrix or whatever you need it to be, and you enter those numbers. So I've already done it here. And then you hit second matrix again, and you go over to edit, and you open up the second matrix, and you make that the answers. Like in this case, it was 7, 6, 0. So basically what we're saying is this first matrix A times the second matrix B equals this third matrix C. And what we really want to know is what matrix B is. We want to know what those variables are. So if this was arithmetic, it'd be pretty easy. If we had A times B equals C, and we wanted to find the value of B by itself, we would just divide both sides by A, because division is the inverse operation of multiplication. But you can't do that with matrices. You can't divide matrices. So I couldn't just come over here and divide both sides by the matrix A. That just wouldn't work, because division is just not defined for matrices. So there is something we can do though. If we multiplied the left side by the inverse of A, because you can take the inverse of a matrix. If I did that, then I would have to do the same thing to the right side. If I did this to the left side, it would make the matrix A drop out, and I would get the matrix B by itself. But then I have to do the same thing to the right side. And you really do need to keep in mind that multiplication of matrices is not commutative. So it's not equal to the matrix C times the inverse of matrix A. That is not what it's equal to, because the order that you multiply the matrices really matters. It's not equal to this. You have to be sure that you multiply using the matrix, the inverse of the matrix first. So it's this. The matrix B, well, let me make the equal sign proper. The matrix B is equal to the inverse of matrix A times matrix C. That's all you need to know. And I've talked for a much longer time than you'll actually need to solve this, because all you got to do is throw that in your calculator, right? You got your two matrices. All you have to do, go over to names. That's where you're able to like grab your matrices. Hit enter on the first one. Whoops, sorry. Second matrix. So you hit enter on the first one. Okay, I'm throwing myself off here. Doing something wrong. Second matrix, and you grab that first one. And that's all you gotta do. Hit enter and just grab it and puts it on the clipboard. And then hit and then don't hit second. So let me do this again. Second matrix, hit enter on A to pull it up, and then just hit matrix button once, because that's the inverse button. That means to the power of negative 1, or it's like treating it like the inverse notation. That's the inverse of matrix A. Multiply that by that other matrix that we grabbed. That's literally all you have to do. That's the whole trick. You grab that, boom. Those are that's the solution to the systems of equations. And I know that it works. I already tested it, and I checked it and made sure it works. So I talked for a really long time. Let me show you how you do it from the top really, really fast. And so in case you're not interested in all this theory and it doesn't help you, I'm gonna just quickly go through it all one more time really fast as a refresher for how we did that. So we just looked at our systems of equations, and we asked ourselves, what are the coefficients of each equation? In this one, it was 2, 1, 1, so we wrote 2, 1, 1. And then it was 2, negative 1, 2, so we wrote 2, negative 1, 2. Then we had 1, negative 2, 1, so we wrote 1, negative 2, 1. And we built a 3 by 3 matrix. And we know that's being multiplied by those variables, x, y, z. And we know that multiplying those gives you those solutions, 7, 6, 0. So then we went into our calculator, and I will show you what we did from the top. I will, in fact, clear my calculator out so that you can see what I did. Second matrix, tab over to edit, open up the first one, make it a 3 by 3 matrix, and we typed in those values. 2, 1, 1, 2, negative 1, 2, 1, negative 2, 1. And then we hit second matrix, and we built another one that was a 1 by 3 matrix with the it was a 3 by 1 matrix with the value 7, 6, 0. And then we go to second matrix, and we grab the first matrix. Here, let me quit out first so that I'm really doing this properly. Second matrix, grab the first matrix, grab the inverse of it, and multiply by the solution matrix. So second matrix, that's that other matrix we got. There's your answers. See, that only took me about 30 seconds or a minute tops to throw those in there. Whereas if you're trying to solve that by hand, it's really hard. And here's a bonus thing. I've also been, I ended up getting another question on my exam that simply said something like, okay, here's a matrix. Maybe it just said this, for instance. Here's a matrix, a 3 by 3 matrix. What's the inverse of it? And it was really nice being able to just, like, if it was just, I'm trying to show you just this guy here. If you just had that and it just said, what was the inverse of, what's the inverse of that matrix? I just threw it in my calculator and went second matrix, and I grabbed the matrix. Whoops, second matrix, grab the matrix, and then take the inverse of it. I just threw that in my calculator, and I could tell you, in this case, they're like really crazy rational numbers, but on my exam, they were just simple whole numbers. And so you might be able to get 2 questions right without having to do any work. So hopefully that helps. Let me know if you have any questions.